Yeah, welcome to the lecture on electrical circuit analysis. So, today topic is nodal analysis. So, the today lecture is on nodal analysis. So, the learning objectives of this lecture is, first one is to understand the what is meant this nodal analysis technique. What is the nodal analysis technique, and the next objective is how to apply this nodal analysis technique to solve the given network problem, to solve the given circuit or network. So, how to apply this nodal analysis technique to solve the circuit. So, solving the circuit means finding something in the circuit. So, finding the current in the any element or voltage across the any element. Okay. So, let us understand this nodal analysis. So, a nodal analysis is a systematic application of KCL, Kirchhoff current law, Kirchhoff current law at a node, and after simplifying the resulting KCL equation, the node voltage can be calculated. That means, nodal analysis means we have to apply the Kirchhoff current law at individual nodes, and once you get the equations, so by solving that equations, we are going to obtain the node voltages. So, this is called the nodal analysis. What is a node? So, node is a node or junction is a point at which two or more elements are joining together. Now, see, let us see this network. So, in this network, this is the one node, okay, this is another node. So, V2 is another node, and next one is this V0 is another node, and next one is VR, another node. So, how many nodes are there? See, for every element has two nodes. If the current is entering into the one node, the current must be leave through the another node. So, those nodes are called simple nodes. Now, so this nodal analysis consisting of finding the node voltages at all principal nodes with respect to the reference node. So, what is nodal analysis means? Finding the node voltages at all the principal nodes with respect to the reference node. So, what is a principal node? Principal node means a node with more than two, okay, more than two elements are joined together, we are calling as a node. Now, see here this node is a principal node because this node is joining this element 1, 2 elements, so 3 elements. See, more than 2 elements are joining at this node, therefore, this is a principal node. Now, see this one V1, so this is a not a principal node because it is joining only how many nodes? 1, 2, so 2 elements. So, this is called a simple node, whereas this middle one is called a principal node, and this ground point, this is also principal node because how many elements are joining here? 1, 2 and 3. So, 3 elements are joining here, so this is also a principal node. Now, how many principal nodes are there here? So, 2 principal nodes are there here. How many principal nodes? 2 principal nodes. So, 2 principal nodes. So, the number of KCL, that is Kirchhoff current law equations to be solved is number of principal nodes minus 1, that is 2 minus 1 is 1, 2 minus 1 is 1. So, you will get the question, objective question that, so the number of Kirchhoff current law equations to be solved using nodal analysis technique is number of principal nodes minus 1, NP minus 1, where NP is the number of principal nodes minus 1, NS is the simple nodes. Now, how many simple nodes are there? See, all principal nodes are simple nodes, but simple nodes need not be principal node. So, total number of nodes are 1, 2, 3, 4. 4 nodes are there. In these 4 nodes, 2 are principal nodes, 2 are simple nodes. Okay. So, how to apply this nodal analysis? See, here, since Kirchhoff current law is valid for phasors. So, Kirchhoff, we know that already, Kirchhoff current law. So, this Kirchhoff current law is valid for phasors. So, we can analyze the AC circuits by nodal analysis also. First, in order to apply this nodal analysis, we have to determine the number of nodes within the network. How many nodes are there? Once you determine the number of nodes, you have to identify the principal nodes and simple nodes. Okay. In that principal nodes, you have to select one node as a reference node. So, that means pick a reference node and label each remaining node with a subscripted value of voltage V1, V2 and so on. Once you pick the principal nodes, select the any one as a reference node, that is generally we select the ground is a reference node. So, the principal nodes we have to label the voltages, that is a V1, V2. If nothing is mentioned means plus V1, plus V1, plus V2, plus V3 and so on like that. If there are two principal nodes are there, so plus V1 plus V2. Where is the minus? So, minus is our reference node which is going to the which is ground. That means the volt current is flowing from positive to negative. Now, once you label this V1, V2, apply the Kirchhoff's current law KCL at each and every node except the reference node. Here each and every node means you have to select only principal nodes. Simple nodes are not considered. Simple nodes are not considered. So, we have to apply the Kirchhoff current law at each and every principal node. So, how to assume this? So, you have to, when you are applying this Kirchhoff current law, assume that all unknown currents, let us say I1, I2, I3, we do not know that currents. So, all the unknown currents are leaving the node for each application of the Kirchhoff current law. You have to assume that all the currents are leaving the junction is equal to 0. So, sum of the currents leaving the junction is equal to 0. See how we can apply the anyway. So, entering currents is equal to the leaving currents, or all the sum of the currents entering the any node is equal to 0, or algebraic sum of the currents leaving the node is equal to 0. But here especially nodal analysis it is very practically used. So, we have to assume that all the unknown currents are leaving the junction, the sum of the leaving currents are equal to 0. So, this is the steps to follow the nodal analysis to solve any problem by using nodal analysis technique. Okay. Now, we solve the resulting equations for node voltages. So, once you get the equations, you solve the any equations, whether you want to use any method to solve the equations. So, if there are more number of equations, let us say 3 or 4 or 5 like that, so it is better to use the Cramer's rule to solve the equations. Now, for dependent current source, if any dependent current source is there in the circuit given network, so treat each dependent current source like an independent source when Kirchhoff's current law is applied to each defined node. And also, however, once the equations are established, so substitute the equation for the controlling quantity to be ensure that the unknowns are limited solely to the chosen node voltages. Okay. So, to understand these steps, so let us solve one problem so that you will easily understand how to solve a given network by using this nodal analysis principle. Okay. Now, let me take this practical example problem. So, practical problem 1. So, what is the question? Find V1 and V2 using the nodal analysis. Find V1 and V2 using the analysis. Now, because I have taken here AC circuits, earlier we have solved DC problems, but let me take this AC circuit. So, source is here AC. So, 10 sin 2t amperes current source and 2 ohm resistor, okay, 2 Henry inductor. Next one is 0.2 farad capacitor, 4 ohm resistor. So, 3 Vx, it is a dependent source, voltage dependent voltage source, plus minus is there means voltage source. So, which depends upon 3 into some Vx, Vx is a voltage dependent voltage source. Okay. Now, what is the first step to apply this nodal analysis technique? The first step is you have to identify the number of nodes. You have to identify the number of nodes in the given circuit. What nodes? Principal nodes. Okay. Now, see here, first V1 is there. So, V1, the V1 node V1 is a principal node because this connecting the 3 elements, one is a current source, another one is the 2 ohms resistor, another one is a 0.2 farad capacitor. So, V1 node is a principal node. Now, V2 node is also principal node because V2 is connecting the capacitor, inductor and resistor. So, more than 2 elements, that is 3 elements is more than 2 elements, the node which connecting the more than 2 elements we are calling as a principal node. So, P2 is also principal node. Now, ground, okay. So, ground is also principal node because how many elements are connecting? Current source, resistor, 2 resistor, 1 resistor, 1 inductor, 1 voltage, dependent voltage. So, 4 elements are connecting. See, the reference node you have to select such that the node which is collecting the highest number of elements, that is called reference. You have to select in such a way such that the node which is connecting the highest number of nodes, highest number of elements, you have to select as a reference node. So, here because this node 3 is I am selecting as a reference node. So, ground. Now, so first one is you have to identify the nodes, principal nodes and simple nodes and taken the reference node. Now, next one is you have to apply the load, label the nodes, that is V1, V2. So, I labeled V1 and V2, that is a plus V1 and plus V2. Now, next step is we have to apply the Kirchhoff current law at each and every node except the reference node, each and every principal node except reference node. Now, see here. Okay, so 10 sin 2t I can write as 10 sin. So, it is angle is 0, 2t plus 0, therefore 10 at an angle 0 degree amperes. I am converting into the polar form. So, magnitude and phase and 2 ohm resistor. Okay, so V1 and V2. Now, I want to apply the Kirchhoff current law at V1. Okay. Now, what is the current here? See, 2 amperes. See, 10 at an angle 0, 10 at an angle 0 current is coming to this junction V1. So, this must be according to the Kirchhoff current law. The algebraic sum of the currents entering into the any node is equal to the leaving that node. So, 10 at an angle 0 is coming to the node, that equal to the, so what is the current flowing through the 2 ohm resistor? So, current flowing through 2 ohm resistor is V1 by 2 voltage, see, potential difference by resistance V by R, I is equal to V by R. So, V1 minus 0, ground is 0, ground is earth potential, that is 0. So, V1 minus 0, that is V1 by 2 plus, so this current, leaving current is how much? So, V1 minus V2, the potential difference between the two nodes, V1 minus V2 by minus J2.5. Now, see here, this is the first equation. So, 10 at an angle 0 is equal to the V1 by 2 plus V1 minus V2 by minus J2.5. Now, if you take this LCM 2 and 2.5, you can calculate that, you simplify that, you will get this equation 1. So, this is the equation 1. Once you get the equation 1, now apply the Kirchhoff current law at the node 2, okay, at node 2, junction 2, so V2. So, the current is V1 minus V2, okay, V1 minus V2 by minus J2.5, this is the entering current to the V2 node is equal to the, what are the leaving currents? Leaving current is here the current flowing through the inductor. So, what is the current flowing through the inductor? So, that is a 5 plus J4, so now see here, so V2 by J4. P2 by J4, P2 by J4, next V2 by J4 plus what is the current leaving is again, sorry, yeah, what is this current? The current coming from the dependent source, that is 3Vx. So, 3Vx minus V2 by 4. So, this one 3Vx minus V2 by 4. Where what is this Vx? So, Vx is equal to V1. Now, see here, what is the Vx here? So, because here Vx is voltage across the 2 ohm resistor, voltage across the 2 ohm resistor, that Vx must be equal to the V1. So, this Vx must be, okay, this Vx must be equal to the V1. So, therefore, we have to substitute that, we have to substitute this V where Vx is equal to V1. So, therefore, if you take the LCM and simplify that, then you will get the equation 2. Once you get the equation 1 and equation 2, then it is easy to solve the equation 1 and 2. So, I told you we can use the Cramer's rule. See, more number of equations. See, put 1 and 2 in matrix form. So, what is the first two? See here, 5 plus J4 is the V1 coefficient and minus J4 is the V2 coefficient. So, 5 plus J4 minus J4 and equal to 100. So, 100 into 100. Now, next matrix is minus 7.5 plus J4 is the V1 coefficient and 2.5 plus J1.5 is the V2 coefficient equal to 0. So, equation, that is a matrix, second matrix 2 by 2 matrix. 2 equations 2 by 2 matrix will get. If 3 equations are there, 3 by 3 matrix. Okay. Now, where is delta? What is the delta? So, delta must be equal to the, what is delta? Determinant of the matrix. So, AD minus BC. You take the delta, so you will get that 25.74 into at an angle minus 29.05 degrees. Now, how to find out the V1? Okay. So, by using the Cramer's rule, V1 V2 is equal to the, so that matrix by determinant into 100 into 0. That means, if you are in order to get the V1 value, so in order to get the V1 value, you have to replace the first column with 100 and 0, first column of this matrix, this matrix A. Let us say this matrix is Z matrix, impedance matrix. Okay. So, this impedance matrix 5 plus J4 column, this first column 5 plus J4 and this minus 7.5 plus J4, you have to replace this first column by 100 and 0. that is voltage vector, voltage matrix, and find out the determinant, that is delta 1. So, in order to get the V1, so delta 1 by delta, that is a determinant of this matrix by determinant of the actual matrix, then you will get the V1 value. Now, how to get the V2 value? So, V2 value here, now replace the second column with 100 and 0, minus J4 and 2.5 plus J 1.5 by 100 and 0. Then you find out the delta, that is determinant of that matrix. Then the determinant of that matrix delta 2 by delta, that is determinant of the actual matrix, will give you the V2. Okay. Now, once you solve this V1 and V2, then this is the value of V1 and V2, 11.32. Now, again you once you get this in the polar form, see here I got the values in polar form, 11.32 at an angle 60.01 degrees and V2 is 33.02 at an angle 57.12 degrees. Once you get the in polar form, you can easily write in the sinusoidal form. So, V1 magnitude and phase, okay, 11.32 sin 2t plus 60 degrees, 60.01 degrees, V2 is equal to 33.02 is the magnitude, sin 2t is the same plus 57.12 is the phase. Okay. So, this is the way how to solve the network, given network by using the nodal analysis principle. Now, next one is supernode concept. What is this supernode means? Now, see here how many nodes are there. So, V1 is there, V2 is there, V1, V2. Now, see here the current is coming here. So, 3 at an angle 0 is equal to the V1 by minus J3, apply the Kirchhoff current at V1. So, minus 3 at an angle 0 is coming, that equal to the what are the current leaving, V1 by minus J3 plus V1 minus V2 by 4 plus what is this current? So, what is this current? So, this current we are unable to find, V1 minus 10 at an angle 45 by some resistance. So, resistance is not there. So, in this case, see, you are unable to find the current in the one branch. See, you are unable to find the current in this branch, how much current in this branch. So, V1 to 10 at an angle 45 degree volt to V2. So, V1 for 10 at an angle 45 degree volt to V2. So, in this branch you are unable to find the current, therefore, in this case you have to apply the supernode concept. Supernode concept means this is what. Now, see, we are taking that node as a only one node, supernode. Now, we have to apply the Kirchhoff current law at this supernode only. Algebraic sum of the voltage currents coming into the this supernode is equal to the sum of the currents leaving that node, or all the currents leaving the supernode is equal to 0. Sum of all the currents leaving the supernode is equal to 0. See here, now it is easy. Now, see, 3 ampere is coming. What are the currents coming? 3 ampere is coming plus, so that is equal to what are the currents leaving? So, V1 by minus J3 plus V2 by minus J6 plus V2 by 12 ohms is equal to 0. So, equation 1. But 2 unknowns are there, one equation. So, you cannot solve this equation. So, you require one more equation. What is that equation? Now, see here, this V1, node V1 and V2, the potential difference between this node V1 and V2, that is V1 minus V2 is equal to 10 at an angle 45 degrees. So, V1 minus V2 is equal to 10 at an angle 45 degrees, you got one equation, and from this supernode you will get the one more equation. So, therefore, 2 equations, 2 unknowns, then you can easily solve this network. So, once you get the 2 equations, you can solve the equation, and once you get the equation, it is easy to find the voltages. Once you calculate the voltages in any node, see here, I have calculated the voltage V1 and V2 for this network. Once you calculate the V1 and V2, then it is easy to calculate the currents. Current flowing through 2 ohm resistor, current flowing capacitor, inductor, you can easily calculate. Once you calculate the current, then it is easy to calculate the power, because power is the product of voltage and current, V into I. So, that is what the supernode concept. Whenever there is a current flowing in any branch, so if you are unable to apply this Kirchhoff current law, that is supernode, nodal analysis, then you have to think that, so there is a supernode concept. Okay, that is the way. Okay. So, thank you for listening the class. We will join in the next class.